Good day bayaw! For today's video, we will solve sample number 2 in chapter 3, Total Hydrostatic Force on Surfaces. For our sample problem, we have a spherical balloon is filled with helium at sea level. Helium and balloon material together weight 500 Newton. If the net upward lift force in the balloon is also 500 Newton, what is the diameter of the balloon? Given the density of the air at sea level is 1.2255 kg per cubic meter. So, before solving, we need to identify the given in the problem. So, in the right side on the screen, we have the given. So, the first one is the density of the air, which is 1.2255 kg per cubic meter. And then the weight of the helium and balloon, or the gas and balloon, which is 500 Newton. And then the net upward lift force on the balloon, which is 500 Newton. And the standard gravity, which is 9.81 meter per second squared. So the concept that we will use is buoyancy minus weight is equals to net upward force. So the formula that we use to represent our buoyancy, or to get our buoyancy, is rho, or density, times standard gravity times volume. So the formula of volume is 4/3 times pi times radius raised to the power of 3, or radius cube. So in our solution, our buoyancy is rho, or density, times gravity times volume minus the weight is equals to net upward force. So the density of air times 9.81 meter per second squared, which is our standard gravity, times the volume 4/3 times pi times r to the power of 3 minus 500, the weight, is equals to 500. Since we can't get the value of our radius here, so we will substitute the density of air, which is 1.2255 kg per cubic meter times 9.81 meter per second squared as our gravity, times the volume 4/3 times pi times radius raised to the power of 3 minus the weight, which is 500 Newton, is equals to 500 Newton. So if we will put this equation to our scientific calculator, it gives us the answer, or the value of the radius, which is 2.77964849. Since the radius is in 1/2 of the diameter, so we will multiply the radius into 2. So 2 times 2.77964849. If we will also put this equation or solution to our scientific calculator, it gives us the answer of 5.42 meters. So now we have the diameter of the balloon, which is 5.42 meters. So that is all, and God bless us all.